Okay, just walking past. Outnumbered, done some cleaning on that. Put the covers up because it's getting quite hot. And yeah, take you on to Paikea. Shane's finishing off the final Staunchion on the starboard side so we can have the Staunchion sockets all done. See where he's at.
Laminating in a hole. That's very not fun to get into.
Last one though, Shane.
Last one, yes it is.
And we have got a bit of a portable aircon going on, trying to get some cool air into that forward section.
Yep. It's currently 32 degrees Celsius, so it's a bit challenging with laminating and stuff at the moment.
So this is all double bias?
Yep. Well, 300 gram double bias, 12 layers in total.
I feel like it's a lot, Shane. How much load does it see that it needs this much?
Heaps. Like, so little spoiler alert here. Ollie managed to break his pump board. Well, Ollie didn't. He gave it to a mate who's a bit heavier than Ollie. And we were really pushing the boundary of it being lightweight. And it's the first time our boys have actually heard a proper carbon part failure. And they said, "Dad, it sounded like a shotgun." Yep. It's because it was under an immense amount of load. It had a whole bunch of potential energy stored in that skin. And all of this has always been on me about how much load does it hold. We worked out what the skin could handle. And the skin that was on the bottom of his board, in the place that it was able to handle a compression load of 3.5 tonne?
Yeah, it was over 3 tonne.
Yeah, I think it was 3.5 tonne. And he was like, "No way, how could it be 3.5 tonne? You know, I'm only 65 kilos. So I showed him a little bit about how levers work, and that his foot on the end of on the front of the board created a long lever to the front end of the mast, so it multiplies his weight by several times. And because we're in a cantilever beam arrangement, how that then translates into bending moments, and the bottom being in compression and the top being in tension, and that results in the carbon skin seeing a force of 3.5 tons. And he was like, "Oh, okay, well that's why it broke." I said, "Yeah, and that's why it sounded like a gunshot, because there was so much energy put into that little skin." So, cool. So it's a bit the same with these sockets. So these sockets we spoke about ages ago, that they only have to handle 52 kilos at the top. 52 kilos at the top of the Staunchion. The Staunchion's a nice big long lever compared to the length of our socket here. So the load that these skins see is quite a lot more than 55 kilos. So this is why there is 12 layers of carbon double bias going on here. That's the secret to composites. It's distributing the load over large areas. So this socket actually sees quite a lot of welly, just due to the fact these Staunchion sockets have plenty of carbon going onto the base.
What's our plan with those cleats there, the horn cleats?
Not a hot leap other than get rid of the aluminium backer plate, put a composite just a fiberglass backing plate.
So we're still going to do through bolts on those?
Yeah. Not gonna do blind threads into those. That's way too hard.
Okay. Nice. So then peel ply?
Peel ply. Boat builder's best friend and worst enemy. Because it's an epoxy laminate, we need a textured surface finish to finish off with, so that this surface finished is one textured, so that helps with the whole sanding process because it's textured and sandpaper loves to rip into the textured surface. So it leaves the textured surface is slightly resin rich, so that gives you actually something to sand and bond to. Now this is another really important note. If you didn't see it on the video where we talked about peel ply, you have to sand a peel plied surface. You cannot bond to a peel plied surface. It is not the best structural secondary bond. And there'll be lots of people, oh, but I bond straight to it, that's fine. It's like, no, it's not. It's not. You can get away with it, but it is not a good prepared secondary bond surface.
It's not best practice.
It is definitely not best practice, and there's heaps, and when I mean heaps, there's heaps of literature in regards to peel ply, surface finishes, and preparing them for secondary bonding. And I know a fair bit about this because it was something I was involved in a little bit, and the aviation industry was talking to us a fair bit about it once upon a time, so it is an area I do know fairly well. Simple way to put it, peel ply, whether it's nylon or polyester, either one of the two are coated, and the reason that they are coated is so that they will release
from the job, right? When you say release, that they will come off.
They'll release from this epoxy when it's cured,
because you don't leave it on there.
Yeah, if the peel ply is not release coated, and anyone that's done the old I'm going to go buy some nylon taffeta from down at the dress shop and use it as a peel ply will know exactly what I'm talking about, and how you have to pull it off in little tiny strips and threads and chunks and all the rest of it. It just does not want to come off. And if you put polyester in there, well, it's part of the laminate.
So that means you have to sand it because it's got a...
Correct, it's got a molded surface finish, the same texture as the peel ply. And if you look at under a microscope, it is very, very, very clear that that is the case.
When you said before about the aviation stuff, was that for Rocket Lab?
No. Long before those guys. I was at High Modulus.
Oh, okay.
When I was in the R&D lab.
Okay.
Got to talk to a lot with the guys from Newport Composites. They're a pre-preg manufacturer. Super cool, really knowledgeable, do some really cool shit. I'm going to need some more peel ply.
Okay. You want me to get you some more peel ply?
Yes, please. You're going to have to go cut that. You do that.
Okay. Alright, there you go. Got him some peel ply.
So I'll reiterate again. If you have a peel ply surface, sand it before bonding to it. Is a wise thing. If anyone wants to get super technical on it, there's some fantastic articles on it. One of those articles is called Curse of the Dreaded Nylon Peel Ply. Not the most stimulating read in the world, but it was a very, very in-depth and detailed study into peel ply and secondary bonding, particularly related to pre-pregs and epoxies and stuff like that. So, yeah. So easy composites.
They need to send us a t-shirt or something, don't they?
Yeah, they're gonna have to send us a t-shirt for giving them kudos. And I should be wearing a mask wearing this stuff.
You should be wearing your suit. You should be wearing a mask.
Yeah.
And you should be... it's very slack of you, Shane. You're usually pretty good with the safety gear.
Yeah.
So...
I don't know whether you notice that the air conditioner is on with the fan going and I'm in here and I'm sweating.
Okay, what's your blue stuff?
Perforated plastic, release film.
So you have how do you work out all your little pre-cut things? Just because you've done it 12 times now and you know how much?
Exactly. I should know it by now, and I'm on to my last one, and I didn't have enough bloody peel ply. It's because I was getting cocky. I knew how much I should have.
Ugh. Yeah.
And then you got a place for it.
Right up my nose. Okay, so the peel ply helps with creating a good surface for sanding.
Correct.
The perforated plastic helps with it not sticking, well, with the next bit not sticking, right? The
Correct.
Fluffy stuff.
Yeah, and there's perforated plastic. The perforated part of its name sort of gives away that it's plastic that's all perforated with little holes. So that means that the resin bleeds out of the laminate in a controlled manner.
Yeah, because it's going to stick.
And the air, yeah, and it bleeds out into our breather / bleeder cloth. That is the next layer above this.
The idea is with this perforated plastic is it only when you're sort of using it in the vacuum bag situation, and as the vacuum presses down on the part, it's going to push the resin out, and it will push through the perforated plastic, and that will sort of make sure that the resin is being pushed out evenly.
Correct.
But the peel ply doesn't do that.
No, peel ply is only there for surface finish.
Is it important to cover every single bit of it? Just as much as you can, because I know there's a couple of little gaps on things there.
Generally speaking, yes, but in this case, I actually want a little bit of extra bleed out here, because this is where I have the maximum amount of overlaps in the carbon. So I need to get rid of a little more resin because it's a bit thicker.
Okay, so now we're going to do
The breather valve.
what's its job?
This allows the air to move around under the vacuum bag so that the vacuum bag doesn't seal off. So we've got the vacuum here, we've got the breather here, whatever's air is here can evacuate out through the hose and into the vacuum pump and create a vacuum. Where there's no breather felt over this side, if this seals, particularly on wet resin, it means that whatever air is here is essentially trapped, because the bag will create a seal with the wet resin here and not let the air suck out. So the breather felt's really important to allow the air that's inside the bag in particular move around and be sucked out by your old vacuum pumpo.
And what do you say to the people who are like, that's a lot of wastage?
Welcome to boat building.
Well, you could just hand laminate it, Shane. Why did you not just hand laminate this?
Because I've got 12 layers of carbon in here, I need that to consolidate around this really difficult geometry. You'll see here I can actually, it keeps wanting to peel off.
Yeah.
So it doesn't want to actually stay where I put it unless I've got the vacuum there holding it up and into place.
And why would you not infuse it?
Because it's even harder.
Then you've got to put it all on dry, don't you?
I've got to put it all on dry, and it's really hard because I've got an external surface. When it goes on dry, it's quite lofty and fluffy. When you vacuum it down, you end up with all these wrinkles that turn up. Also, I can't guarantee, because I'm on the old existing hull laminate here, how airtight the laminate is. And yes, laminates are not usually airtight unless they've been laminated really well by someone good. Laminates like this are generally quite porous. A very interesting conversation with a very large boat building yard in New Zealand once about that, with a keel of their very big power boat, where they missed a couple of layers during the build schedule, and they wanted me to investigate whether the part could be repair infused, because no one wanted to grind it back and hand laminate it because it was going to be a nightmare. And I said the first thing I'm going to do is to check the
Porosity.
porosity of the keel, and they're like, it's the keel of the boat, it's like 20 mil solid glass laminate thick. I said, I don't give a shit, it's probably not airtight. And they wouldn't believe me, and I said, look, I'll just do a vac test on half of it, and if it's half of it's good, then I'll show you how to do the repair, and off you go. And sure enough, I did the vacuum test, and it leaked like a sieve, and all of these solvents came flying out of the laminate, and there was all these wet patches. This is a boat that is still in the factory being built, and the breather felt that I used under the vac bag to set it all up was getting wet in all these splodges because of the solvents that were still trapped inside the solid laminate. So it was a bit of an eye opener for me. It was certainly an eye opener for the yard. This is a very reputable yard.
So when you say solvents, what are you talking about? What sort of?
So it was a polyester built boat. So there's a lot of solvents in the resin to make them nice and thin and all the rest of it.
Copy.
And in particular, there was a couple of techniques that they were using during the laminating process where they'd have to clean the rollers with acetone. And that process wasn't the best practice. So there was a lot of acetone and stuff that was transferred.
Yeah, I was going to ask if it was acetone. Okay, what's next?
Stuff. Where is just next to you? There's the glass jar, my resin trap.
Resin trap.
Yeah, and a hose, vacuum hose attached to it.
Uh-huh.
Cool.
And there's...
So this is all about the being prepared. So every stage and every step of the way. There's bish bash bosh. Because if you're running around trying to find something, the resin is still going off. When it's 32 degrees, resin goes off fast. So this is the really slow resin, so that I'm trying to maximize my cure and gel, maximize my gel times, not the cure times.
I'm going to interject here for a second. If you just watch how Shane put that on, he went from the outside and he put a pleat in there to give him a little bit of room to go around the geometry, and then he works in and then he puts a pleat in the middle. So that's going to give some shape to the bag so that when it comes time to put a vacuum on it, it's going to give him extra bits of plastic where he needs it and take it away where it's not needed, basically. So you've got to think about how you're putting that bag on.
Correct. Yeah. Super important part of the process, as Anna explained. Making sure you get your pleats in, and without being silly, your vacuum bag can never be too big enough, but it can always be too small.
Yeah.
So you're always better off having a bag a little bit too big that you've got to put a few extra pleats in than having one too small, and it bridging. And bridging is your number one enemy.
Okay.
When it comes to vacuum bagging.
And just explain what you're doing there with your tube in your resin trap.
Yeah. Vacuum tube with the little breather felt flag on it. I'll get you to open that hatch, and outside that hatch is a vacuum pump with a hose.
Okay.
I'll get you past the hose in first.
How much of the vacuum pump do you just want the hose? Okay, here's hose.
Okay, I'll get you to fire that vac pump up for us, sir. And you can close that hatch.
Okay, vacuum pump on. Hatch.
Okay, and then now Shane's just got to make sure that the bag sits the way it's supposed to.
Yeah, and then I can get a vacuum.
Yeah,
So
that's true.
The base laminate that I'm bagging to is not the best surface, but
Oh, I can hear a lot of air leaking.
oh yeah, like the leaks at the moment. And now, when I'm setting my bag up here, I want my bag to be a bit leaky, so you can see I can manipulate the bag while I don't have a huge amount of vacuum on here. And the main really big thing I'm focusing on is making sure that I push in these internal corners so that I don't have bridging. Bridging is your worst enemy in a vacuum bag, because that means the vacuum bag is not pushing the laminate down in and onto your job.
Okay, and you can see all the resin coming through, all those spots?
Yeah, all the spots are happening now that I've started to seal the bag a bit more.
Explain what bridging is.
Okay, so I've got a corner like this, and here my hand, my hand is the bag. If my hand, there you go, there's the corner of my part, the bag goes here, that bag is bridging the corner, so it's not pushing down. What I want is that bag to go down and into the corner so that it pushes all the laminate down into that corner, because if it's bridged like that, it will not push the laminate down and into that corner.
Just got to touch all the surfaces, doesn't it?
Correct.
Oh, there it is.
This is one of them. There we go. That's the major links done. And now I really reinforce. Okay, so you can see here now the bleed out that's happening. Now it's bleeding like a, I'm not going to say it, but a lot. And you can see here there's a bit of extra laminate and resin stuff here, so I'm actually going to mechanically and manually push this down, push the laminate round to where I want it to be. The vacuum pump is just a clamp. It's an atmospheric clamp. It will not by itself magically put all the carbon and stuff where you want it. You still need to push and pull, particularly on complicated geometry like this. You need to push and pull and maneuver stuff to where you want it to be. So if there's a bit of a ridge that happens here, because as the bag's gone down, everything's sort of, all the layers of fiber are coming together, there's a potential for it to wrinkle. So I'm trying to push it. What if there is a wrinkle wanting to appear there, I'm pushing it, manipulating it down so that that wrinkle goes away, and we end up with a really nice smooth socket. And we can go and look at, again, you've probably seen all these sockets finished, but we'll just reiterate what it looks like when it's finished, that there's no wrinkles or bits and pieces, that it's basically the bag has gone to exactly the correct geometry that I want it to be, and it's going to hold it there, most importantly, because the bag is a clamp.
Yeah, and we'll probably leave it for what? For the evening anyway.
4 hours with this resin. Like this at the moment, I would say is probably about 40-45 degrees Celsius.
Oh, so it's quite hot to touch?
Yeah, it's warm, quite warm to touch. So it's 30 odd degrees outside. So the laminate, the actual boat that I'm laminating to, is fairly warm. The air inside is a little bit less because we have got the air conditioner going, but you can see it's pretty warm in here. I'm still sweating. But yeah, this resin is not exotherming. It is, yes, it is exothermic because it's getting warm, but it's not got a runaway exothermic problem. So the chemical reaction of the resin curing generates heat. So you've got to be very, very careful, particularly with laminates that are a bit thick, like this one. It's quite a thick laminate where it goes through here. The thickness of the material is quite thick, so there's a lot of material and a lot of resin there. And if I was to use a fast resin, it generates a lot of heat very quickly, which then accelerates the cure, which then makes it hot, which then can potentially lead to an exothermic runaway, and you end up with those that have used West System fast epoxy in the tropics will know that it smokes in the cup when it when it runs away. So
we made a boat in the tropics in the middle of summer. And using West System. And we used to start the lamination whenever we had a big lamination sort of piece to do. We would start at like 10 o'clock at night.
Correct.
And just try and get it done overnight while it was cooler.
It was not fun either. But yeah, that's a very good bleed out. That bleed out is a bit too much in that when I was laminating, really wet because it was a case of I have to laminate fast. Speed was the only way I could get this done while making sure that it didn't go off on me. So
it is quite a wet.
Yeah, it's really wet. So I just smashed all the resin on, knew that it was really wet, and I knew it was going to float a little bit on me, so whatever. But normally you don't want it to be bleeding out this much. You want to see all of these dots.
Like dots.
Okay? But sometimes in some cases, this is a classic case where you got to prioritize one thing over the other. You laminate it wet, get it on there fast, smash it on there, and then you do use the fact that you're going to vacuum bag this thing to then bring things back to being the right thickness and the correct fibre to
ratio.
Fibre to resin ratio. So
you have
pretty close to full vacuum.
Okay, that looks pretty good.
So
we'll leave that for this afternoon and turn it off later.
Yeah, turn it off this evening. Now I've got to crawl out of my little hole here. Alright, this thing, super highly technical piece of equipment, this.
It's my olive jar.
That's not olive, is it?
Oh, maybe chickpeas.
Yeah, so it's just a glass jar, and you can see there's actually a bit of resin rattling around in there from when I didn't totally cock up an infusion, but if you infuse something and you have a racetrack or you let the resin run too long, so you end up with resin coming into your vacuum line. And what happens is this jar is super highly technical in that the resin will drip out of the hole here into the jar. What you really don't want is resin going into your vacuum pump, because it's almost instant shutdown for the vacuum pump, depending on what resin you use. So when it hits the vacuum pump's nice and hot, accelerates the cure of the resin, and you end up with this oil infused, semi-cured resin that stops your vacuum pump from working. Not a cool look. So yeah, high-tech jar. In this case I went super high-tech and put a 3D printed lid on it, which accepts the diameter of the hoses and also the vacuum gauge. Also, we have a super highly technical piece of sticky tape, two pieces actually. The first piece of sticky tape has a pinhole in it. The second piece of sticky tape goes over the pinhole, and when infusing vinyl esters and polyesters, like we talked in an earlier video about, we don't want the volatile boil out, so we don't want full vacuum after we've finished the infusion. So to back off the vacuum, so you can see here I've got full vac here. If it was a polyester laminate that I was vacuum bagging now, I'd actually peel my sticky tape back a little bit and just adjust how much air went in here to then back the vacuum off to approximately 0.8 to 0.75 of an atmosphere, or 0.8 to 0.5 of a bar on our vacuum gauge. So that's what this highly technical piece of equipment is. It saves your vacuum pump from being destroyed. That's its main purpose, and its second purpose is that I can monitor the vacuum and I can adjust
Control
the amount of vacuum in my bag.
Oh, there you go.
Yeah, super high tech.
And then tell me about the beautiful Staunchion. Is there anything else you'd like to finish off on that? It does look rather nice, Shane.
That's the finished product. We don't have wrinkles in there. We don't have any bridging in there. The carbon has conformed completely to the base geometry. So it's it's happy days.
Look at that bit of beautifulness. He's very proud of himself.
And this one's not as pretty as actually as the next one along.
Oh,
One I did before. So
I think they look beautiful, Shane. I'm slightly tired. I think they look really nice.
but anyway. It's just
That's
another day, another afternoon in the life. Not even an afternoon. That's another lamination in the life of this boat, this project. And